Hi, good morning, everyone. Let's screen share. Do you see the title as a full screen from PowerPoint?
Yeah.
Yeah, perfect. So I'll start a little bit early and probably finish a little bit early as well. That will leave some time for discussion, hopefully. Thank you so much for having me, first of all, Astan. It's been a great presentation so far, very excited. And the audience also is probably a little bit of a mix of different researchers or professionals or students. And here I come a little bit from the product side as well. And I really try to not make this as a product presentation, but you will see, and I will describe. Our mission is to really leverage good practice, good daylight simulation in the industry. So a way to do that is indeed to make products. So I will talk a little bit about how we work in optimizing daylight simulation workflow and using the openBIM and web technologies. So my name is Franz Forsberg, and I'm an architect specialized in sustainable environmental design. And I worked with André and Stian for quite some years in a large Scandinavian firm, working with parametric design, building performance, optimization of BIM processes, and so on. And of course, during this practice, I got to know pretty well our industry, and also to get very frustrated about many things, namely daylight simulations, or actually not about the simulations themselves, but I would say how we communicate the results to the design team and how we can actually integrate the simulations once simulation is finished running into the design process of the work of the designers. So we started the company Data Trees to solve some of this frustration and to deliver our solutions to a broader audience than just for that specific architectural office. We are at the moment based in Norway and Sweden, but we are of course interested in helping any designer around the world. And what we do very shortly is we develop design tools within parametric design. We do methods, we have methods such as data extraction, machine learning, environmental simulation, automation. And we believe architects and engineers should focus their work on designing better performing building, and that the work of documenting and reaching to good decision is something we could make faster and easier. So we are building tools to let us be more aware of our environment and to make more informed decisions. So now a little bit about optimization of daylight simulation. Why is that important, first of all? So let me talk about a little bit of a raising concern I see our industry and society is facing. And I just want to make a pause and note here that you may hear speak generally about some things, but I often refer to the industry I know the best, which is Scandinavia or some part of Europe. And I know you're far across the Atlantic, so just note that somewhere. So the awareness of the important role of daylight is, of course, increasing. And in Scandinavia, we have like building codes for, each country have their own building codes and regulation. We also have green label and standard recommendations. And in Scandinavia, we are imposed by building codes to deliver satisfactory daylight condition. Doesn't mean, it's not more precise than that. And each country have different methods for compliance, varying from simple window to floor area ratio, or the daylight factor, or climate-based metrics. But even more challenging, I think, than the regulation is those new BREEAM or WELL standards that now come with climate-based metrics almost as a requirement, and often expect the designers to simulate every single room in a project. And I will show how that's difficult in real practice. So the architects, in an architect project, we have different stakeholders, and each have their own opportunities and challenges regarding daylight. In a way, the architect has the legal responsibility to provide satisfactory daylight condition, but they lack the knowledge of documentation and design. So he will delegate that task to the engineering consultant, which will do the evaluation, although their workflow are quite incompatible with the architect's design process. And who is really concerned about this is actually the developer, who wants to have great customer satisfaction, but may have constrained budget. And municipality will be doing the audit, but they like efficient quality control procedures. So working myself several years with tasks like daylight evaluation, I found that the traditional ways of working were very inefficient. And I couldn't help to think that the status quo had to be disturbed, because we are facing a pressing need with tighter regulations coming every year, new standards. So we need to make our building stock more resilient, and we are facing unprepared industry. So I did some research to understand the practices, perhaps the struggles in daylight assessment in my extended network, again, mainly in Scandinavia. And here are some findings. I saw that in Norway, most half of the building permit assessors in municipalities will look at daylight in projects to give a building permit. They don't know if daylight factor is a good indicator for daylight. And daylight factor is like a pre-accepted mean of justifying good daylight in our regulation, in our building code. So actually, they're assessing something they don't know about. And as many daylight simulation practitioners, architects or engineers believe it is, or as many do not. So even people who practice disagree on the metrics. Furthermore, 80% of them have never done climate-based daylight simulations, and reasons are multiple, and many of them claim it's because they don't have the appropriate software. So little wink to Climate Studio on marketing. And finally, daylight consultants spend on model conversion and remodeling generally between 20 to 50% of the evaluation time, and often more than 50%. So all the money which is spent in doing a daylight evaluation is actually a dumb interoperability issue, not on giving expertise. So daylight evaluations are often left aside due to poor practices, which can originate from lack of daylight knowledge, workflow incompatible evaluation methods and software, or economical restraint from the developer, or poor design evaluation difficulties from municipalities. And when daylight is assessed, it's not always performed in the state of the art. Practitioners are not all educated in daylight design, actually, at least in Norway, where most of the consultants that do daylight, they're actually educated as energy consultants, and they just do daylight because there is a market for it. So they don't actually do they don't do such a good job. And the understanding of the climate-based metrics also diverge also. So that leads to quite a bad understanding of yearly and seasonal conditions, and then bad evaluation of projects. So there is a kind of a compliance chasing being the standard practice. where daylight is only assessed to tick a box and not really to provide value for the users. So there is great potential to do better, namely optimize. Optimize, Google tells us very quickly, is to make the best or most effective use of something. And regarding computing, they say about rearranging or rewriting data or something. And we could do that as consultant. We could optimize to be able to deliver more value, so we could work less, not because we want to be lazy, or not only, but so we can lower our costs and then assess more projects, because there is a need in assessing actually more and more projects. So to achieve this, to optimize, I'm going to use, or we use a tool which is the wisdom pyramid. And we are going to see how we can climb this wisdom pyramid. Actually, we can also change a little bit the definition and fits daylight problematics pretty easily. So I'll go quick about how to climb the pyramid in 4 steps. In a nutshell, first, what does a daylight consultant do? Well, we provide expert opinions, analysis to organizations and individuals. We provide strategies to prevent problems and to improve the performances. So the consultant is actually on the top of the pyramid, or it should be. And then we had an interesting question at the data trees with my 2 partners, and we're asking, can a consultant be replaced by machine learning if we really want to be able to leverage more projects? Could I be replaced by Albert, our mascot? Could I automate and delegate to Albert the task of providing expert opinions, analysis, and recommendation? To succeed, I will have to teach Albert how to climb the pyramid. Albert, which is our AI. And perhaps I should say, can a consultant be aided to be a little bit less scary? Albert needs data. It needs a lot of data to build its experience. And we can collect valuable data from the projects, from the BIM models. Some metadata, of course, but mostly the geometrical information that the architects already produce. No need to remodel something which is already, in theory, given to us, at least in Scandinavia, where BIM practices are pretty well developed. Then we need the daylight data. And for that, we simply have to perform annual climate-based daylight simulations. Then Albert could present the data to convey some facts. Using the various climate-based daylight metrics, Albert could tell about the daylight availability in space or in time, its uniformity, about the daylight sunlight conditions, glare potential, anything. Here I want to emphasize on users should recreate the daylight metrics themselves. Only then we can really be sure that we understood them, even if they come out of the packages given to us. I think it's good exercise to just remake the formulas. And Albert lives in the cloud, so he will need to use the web browser as a communication platform to reach the audience. The web is device neutral and accessible to everyone. We need to now teach Albert how to contextualize information to give a practical understanding. So, because it's very important for designers, which are maybe not familiar with daylight, to be able to quickly respond to if the project complies or not with a requirement. It's important to rationalize the metrics into a simple yes or no answer. No need for fancy heat maps most of the times. Then Albert can now give knowledge in a very simple and clear manner, especially when a whole project has to be evaluated. And sometimes the questions may be a bit more subtle, and you would like to know if, for example, an east-facing room receives satisfactory daylight in the morning or in winter. Therefore, it's important to go beyond the standards and dive a little bit into the research for inspiration. And here, I just want to show a paper I really like, and I read a lot of research papers, so thank you for everyone in the audience which are part of the research and academia. This paper by Timur Dogan from the Cornell University was trying to complement our understanding and methods of assessing daylight. And the last step about wisdom, it's about making a sensible judgment. And this is what humans are good at, but how can Albert possibly make a sensible judgment? Well, if we cluster different room level recommendations and train our data properly with machine learning, Albert could do the heavy lifting of the consultancy. Of course, it's important for us, the teachers, the daylight professionals, to always supervise and eventually correct Albert's recommendation. Involving the user, of course, is key to the success of a collaborative platform. So we saw that research, regulations, recommendation progress, there is a need for spreading the advancement and better understanding of daylight. So there is actually a need for a tool for collaborative decision-making, joining the designer and the consultant together. For greater user value, this collaboration and this platform is expected to be convenient and fast and reliable. So this is our short preview of our attempt in data trees to create such a platform. So here we are on the web. I don't know if it's moving. Maybe it's very laggy simply. Where we can see all the project settings, input data, and simple red and green rationalized way of seeing the results, and also possibility to dive into each metrics to see the point value in the 3D model. So how do we do that? Let's try to step away a little bit from desktop application a bit and see the potential alternative technologies. So our market is very BIM dependent. Everyone can use an AFC file. And architects, at least in Scandinavia, they export AFC files weekly. And they contain classifications of elements like AFC spaces and all necessary geometrical information for a daylight analysis. Focusing on the web, computing can be done on the cloud. Every device, every phone, a tablet, a laptop, any operating system can access the simulated model in a 3D application. There is no need for having files on the computer. And with even smarter understanding systems which understand topology, parametric geometry editing could be possible. I will come to that later. And also in the last 4 years, machine learning has been made possible in JavaScript, meaning on the web, even from before, but now it's very popular with this library. So it allows for smarter applications and user experiences to be created. So about pre-processing, the daylight model conversion can be done on the cloud. Of course, quality assurance is important, but a sharp eye can quickly estimate the validity of the model. And performant custom algorithms can understand the project and classify rooms in a residential project, for example, per apartment, and set daylight parameters automatically. So here we have the IFC file. And here we have, for example, a converted model to a daylight model, where light reflections values are set automatically, as we can see on the grayscale. Calculation speed also has greatly increased with multiple CPU server solution or novel radiance-based path tracing. And we even have another one now with Matthias' presentation. So custom architectures are possible too. About post-processing, data, geometries, other IFC metadata are published to an online platform directly after simulation. So no need to give your computer a hard time with CAD software, dependencies, heavy local calculations locally. Yourself and the design team can study the project on a phone, on a tablet, anywhere within a minute after the simulation is done running. Raw simulation data, the lux values per hour of the year, are then exported or created on the server, and that computes the different climate-based metrics. So working with lux values, it's then possible at any time to create new functions to adapt or create new types of metrics. And the metrics are then benchmarked against the local building code regulation or the certification scheme for that project to give a very quick and easy overview for the less experienced users. Well, of course, Radiance is the god here. What else? But only if it's used in accordance with all the standards and certifications. Reliability is also ensured by measuring various metrics and looking at them together, understanding the strengths and weaknesses of each. Here I have an example that I like to use very often, where we have this room here with 1.3% daylight factor. And too many consultants, in my opinion, would judge that the room here facing north has better daylight condition. But if we look at spatial daylight autonomy, UDI, we can see this is not the case. And what is dangerous is actually what a bad daylight consultant would then advise to do to meet the requirements. So it's really important to have different tools in your toolbox. And data is knowledge, so we must train it properly to make it help us drawing meaningful conclusions. Have your own butler at your service. So I invite everyone to take the lead and to create your own collaborative platform, support the industry, continue supporting research. And that could be it, but there is more. And there is more because this platform called Autonomy is our first project, and we have since been working on something new. We are currently developing a new design tool that we call Spatio, where we bring those new technologies a little bit further. Because we believe there is a better way than using CAD software or BIM tools, especially until the building permit, where documentation for construction is not needed, to design and optimize buildings. So Spatio is a web tool that allows you to design buildings in the browser. It's built with different parametric topology building blocks. So the whole project is structured as a data tree. The interesting here regarding daylight is then the relationship we have between spaces and elements of each spaces. So every aperture is connected to a space and so on. Because what we can do then with this structure hierarchy is, for example, select one bedroom and set reflections values automatically. Or you could do queries. That allows for really a flexible pre-processing of information. And it's also allowed to design through the magic of real-time simulation. And with real-time, we mean like less than 1 second before you get a result. So a little bit about the daylight prediction process. Of course, we need a lot of training material, and input data, simulation with Radiance, and then the prediction. We have seen many image-based daylight machine learning solution on web. You're a little bit curious. But we chose to go with a different approach, which is to predict point values for each point in a room. So here is a very traditional machine learning workflow. Basically, get data, clean the data, visualize it, and do a lot of pre-processing so you're sure that what goes into the model is proper. Then choosing different models for the algorithm, the training, and then saving and loading the model and prepare it for production. If we focus a little bit on the data side, so we are looking at the moment in what would be adequate data for point in time, for point-based prediction. So we are actually at the moment evaluating different in data. But for each point, we're actually looking at what is my distance to the window? What is my angle to a window? And what is the visible area of a window? Because if I have a 1 square meter window and I stand in front of it, it will be 1 square meter. But if I'm far off with the angle, the area will be less. What is the window sky index or the sunbeam index? And can I climatize the sunbeam index? And what is the obstruction angle? And what is the window dimension ratio? And all this for a wide range of rooms and context situation. And what's also important here is to kind of reduce this list and make it the most relevant as possible to avoid very complex models. And what we get out of it is then daylight factors or different daylight metrics. So then regarding the next steps is we are looking at numerical data and not comparing images and images, for example. We are looking at predicting a real number. Model discussions about the model training and saving and loading and how this is happening on the client side in your web browser will be discussed in another occasion. And the deployment is, of course, the browser. We want this to be in the browser. So as you place a window, you instantly see the performances of your design and you can rewrite them. And of course, we can contextualize them easily with your regulations. And we're also very interested in how we could leverage consultancy so we could give sensitive recommendations for under or overperforming scenarios, like uniformity issues, a glare risk, if a task area, for example, a desk, is under a threshold, and also relationship to other building performance metrics. In Spacio, of course, we can upload an IFC, so you don't have to draw the whole model again. Here, interoperability is very important for us and for you. So the models are not only uploaded, it's not only the geometry that we see, but it's the conversion of geometrical model into a topological relationship model. And of course, live correction to Rhino, if you actually don't want to predict, but if you want to validate results, then of course, machine learning is not adequate. You will use traditional simulation tools, but maybe you can't wait for half an hour or hours of computation to get an answer. Maybe it's enough to have like a 95% assurance, and you can tell the architect about, or maybe you're yourself the architect, and then you can decide within seconds if your design intent is appropriate or not. And then validation can come when the simulation is finished. It also allows you to evaluate against other environmental aspects, such as comfort. So stay up if you want to be informed. We have a waiting list. We have a blog where we post a little bit about those research. And regarding autonomy, also we have a demo on the website if you would like to try the tool to get inspired to make your own. And on that, I want to say thank you for having me and looking forward to hearing the other presentations.
Are there any questions or comments? You can see
our question is how much machine learning predictions are trusted in the industry.
Thank you for the great presentation. I'm curious, how do you think about like interpretive, like how can we interpret machine learning algorithm? Like as a designer, we do decision making, and then by using trained machine for our decision. But how can we understand the machine, and then how designer can use that innate algorithm to our design process? Or I feel like it might be a little bit hard if we cannot understand as a human what is doing that machine. It's hard to utilize the full potential of the ML. So I'm curious what you think about that.
Well, of course, there is quite some time in preparing the model, and it has to be kind of validated. And here is, you will prepare, or us will prepare the model. We want them to be at least 95% accurate. And architects and building design in general, we are focusing on two things. We want either very fast answers, but they don't have to be so precise, because I want to have a thumb up or down to know if I can continue within my design right now. And we want validation with really precise answers and validated methods for documentation, for authorities, or maybe just for myself to be very sure. And I think both sets of tools are extremely needed. And we have had for a long time only the time requirement documentation tools. And here we are trying to kind of fill the gap with the primary set of tools, which is, I'm an architect, I'm designing something. Can I go forward, or do I have to wait a week before I get the PDF? You telling me it's not okay. And of course, the machine learning model will have to be, yes, like I said, validated for up to a threshold that you feel comfortable with.
Yeah, thank you so much. Thank you.
Anyone else? Oh, Rob just says me too. It's okay, so there actually are some questions in the chat coming now.
Look at them too.
I'm gonna pull them up.
Do you think, well, what we're looking at is really like having the feedback within a second. So I doubt that increased GPU, CPU will be able to give you that. So I think there is always relevance for machine learning. And I'm not like a pro machine learning by any religion or anything. I just, by experience, know what's expected kind of from designers. So I think it's a tool, a method that has potential, and this potential should be utilized. And about the validation rigor studies against the original, we are actually in this training phase, so it is ongoing. And the whole goal here is for us to give at least 95% against our data set. But the good thing is we also create the architecture of the system so that when users use, for example, Spacio and design new projects, new rooms, new scenarios, that everything which is created will be served as additional training data for the system. And we couple the training and the validation together. So when there is a new scenario, it goes for training, and it also goes for the validation using Climate Studio and any to benchmark the model. You are.
I'm Robert. I am somehow wondering about the import of the IFC into your tool. Are you? Well, the story is it will be easy, but reality is it is a nightmare, or
Yes,
it is.
It is, the reality is it is a nightmare because it's an open standard, but there are so many ways in describing an IFC actually, and architects draw buildings in BIM tools only thinking about themselves, and it's nothing bad. They're just not being told that someone else may use the data somewhere. So the reality is not so simple. With really well modeled model, it's perfectly fine, but there are often issues. Therefore, we believe it's important to have a good native design tool where you could easily recreate either the whole building or simple room geometries, or import what you can of a building and then model the rest. But unfortunately, yes, in any software, it's difficult to import an IFC file, especially when you just don't want to import the geometries, because that's easy, but to do something with it.
All right, well, thank you so much. Oh, one more question, then I'm gonna switch us over to the next presenter. John from Saloma looked like he has a question in the chat.
Yes, but we are looking at point values, and as in one point you will be so far away from the window that you will receive quite very low daylight, and after one moment you can be further and you still don't receive less than 0. So we don't need to create huge rooms, for example. We just need to create scenarios where the minimum and the maximum dimension space is giving you the world possibilities. And then if you extend that space to further darkness or further lightness, things still correlate somehow. Difficult to imagine.
I think John means in terms of like fenestration details and skylights versus side lit openings, like all the different things you can do in a design.
True. So we are, and like I said, we have seen many machine learning attempts to predict daylight, but I've seen 0 of them that include context or contextual geometries. And that's where also we want to do things different. So that's why we are using actually the sky view index and not the vertical sky component. And because the sky view index, we're then taking it across a grid of points on the aperture, like we can then normalize on the area of the aperture. And we are also using the sunbeam index and sun vector. So where is my average sun vector when I have contextual geometries? And then we also take, when I said clematizing the sunbeam index, that's also an interesting topic, because the sunbeam index is basically just a value, a vector. But what information of the weather data in those sun positions can I take to kind of climatize this index to give more valuable information? So the attempt is not to recreate reality. For that, we have validation. The attempt is to give, within an acceptable margin of error, a quick indication for the designer if what he's doing is a good thing or if it's a less good thing.